Hi everyone, this is Mrs. Parr, and on this episode of Math Up to Par, we are going to be talking about points, lines, line segments, rays, and angles. So let's look at this chart right here. Let's read the definition and let's decide what the term is that's going to be used to describe it and a picture to represent it. So this is a location in space. It has no length, width, or height. So this is actually going to be called a point. A point is an exact location in space. When I draw it, it just literally looks like a dot. And I'm going to show it to you like this. I'm going to draw it in red. Doot. That's my point. Okay? So there's an infinite number of points, but that's typically how we represent them, okay? With just a little dot. So when we take all these points and we string them together, and we get a collection of points that go on and on and on to infinity that way and infinity that way, all the way to across the other side of the earth and all the way around and all the way to outer space, and it never, ever, ever stops. Infinity is just such a hard term to grasp. But it's a collection of points, and it goes on and on in both directions. So it goes this way all the way in one direction and this way all the way in one direction, okay? That is called a line, okay? Simple enough, right? A line. When we represent a line in geometry, we are going to represent it with two arrows on each side, okay? So I'm going to draw it this way, and I'm going to make sure that it also has an arrow going the other way, okay? So I am going to represent my line like this. A lot of times a line will have points on it, okay? So you might see some points on your line, okay? Whoops, that's too big. You might see some points on your line like this, or you might not, okay? But a line has an infinite number of points. So just because there's these 2 points here, and they might be named, they might have names A or B, there's an infinite number of them. I've said that a bunch of times. It's like infinity times, right? So this next definition tells us that this is part of a line. It has 2 endpoints. So a point at the end is an endpoint, and it includes all the points between those endpoints. Okay, so that is a line segment. Okay, that does not have arrows. It is typically just a line, and a lot of times it is represented with a with 2 endpoints at the end, but sometimes it can look like this. So it might have these points at the end, or it might just be straight, okay? And that is called a line segment. Alrighty. Take this, we're gonna make it smaller. All right, so we've got our line segment. Now this is part of a line. It has one endpoint and it continues infinitely in just one direction. So if this is my endpoint and it goes all the way this way, it stops right here, so it doesn't go on this side, but it goes on and on and on in one direction, okay? That looks like this, and it can go in either direction. So it could go this way, or it could be reversed and it's going the other way. This is called a ray, okay? I like to think of the sun's rays. You know, when you're sitting outside and you're soaking up the sun's rays, the end point is the sun. It starts at the sun and then it goes on and on forever, you know, and it touches the earth and it touches the other planets. So those are the rays of the sun. The very last one is formed by 2 rays with the same endpoint. So this is our endpoint right here, and it actually shares an endpoint. So it looks like this, and these can take many different forms. So these are called angles. Angles can be different sizes, okay? Angles can be really, really wide open, and so they can be called obtuse angles. They can be really, really tiny with a small opening, so they could be called acute angles. or they could be 90-degree angles. A 90-degree angle is an L-shaped angle. I'm going to show you that over to the side right here. That would mean it was going straight up or down like this, and it creates a perfect corner, okay? And so it could be going any sort of different direction, okay, as long as this is opened at that perfect corner, that perfect L shape. It could be faced any different way, but it's that perfect sharp corner. So that's a 90-degree angle or a right angle. Right angles are going to be important for you to know, especially when you're looking at shapes in geometry. So let's talk about these types of lines. Okay, so we've talked about lines and line segments and rays. So let's talk about when there's more than one and they're crossing over or next to each other. Let's talk about what they're called. So let's say these lines cross and they have one point in common. So I'm going to draw it right here, and I'm going to draw another line right here. Okay, so they are crossing right here. These two are line segments. They don't have arrows, but I can represent these with lines, line segments, or rays. So this is their one point that they have in common. These lines are called intersecting lines. Okay, intersecting lines. Okay, or line segments or rays. And so they cross at any point, okay? These lines are special intersecting lines that form right angles where they intersect. So we just talked about right angles. So let's see right here, if we have a line segment like this, and then we have another line segment right here, okay? They are crossing at a perfect right angle, okay? So you see how it makes that L-shaped there, L-shaped there, L-shaped there, all four of these. So they could be crossed further up, right in the middle, any way, but see, they're perfect angles no matter where they cross. These lines, when they cross at right angles, are called perpendicular lines, or perpendicular line segments, or perpendicular rays, but they are called perpendicular. Okay? Now, these next pair of lines they travel the same direction the whole time, and they never, ever, 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 ever cross. So if it's going this way, there's another line that goes this way, okay? No matter how far they go in either direction, they would never cross, okay? I might have them going up and down, okay? Or I might have them diagonal. But when you look at them together and they're a pair, they are parallel, okay? So no matter what is happening, they are never going to intersect at any point. The way I remember parallel lines, and the way a lot of people remember parallel lines, is it has two L's right here that are parallel. They look like this. So it helps me remember these two lines do not intersect. Okay, let's look at this figure right here. A bunch of lines and rays and line segments just thrown on this page, okay? And each of these points, so some of them are end points at the end, some of them are just points on the line, they have names. And so we can use the names of the points to name our lines. So look at ray AB and look at line segment GH. These lines, no matter how far these would go, they would never intersect. They're going the same direction and they're the same space apart. So these are parallel to each other, okay? Now, line EF is intersecting a lot of lines. It's crossing through ray AB, it's crossing through line segment GH, it's crossing through line CD, okay? And then line CD is crossing through ray AB and line segment GH and line EF, okay? Now, when you look at CD, you don't think it's crossing through, you don't think it's intersecting GH because it's not touching it, right? But this arrow tells me that I would extend it further, right? So if I kept drawing it, it would eventually intersect, okay? So let's look at some real life examples and pictures, and let's see if we can find some examples of how parallel, perpendicular, and intersecting occur in nature. So these are railroad tracks right here, okay? So you see like each of these little slats right here, my lines are far from perfect. In fact, they're pretty bad. But these lines, they run parallel to each other, right? Okay, because they are the same distance apart and they're not crossing. However, if you look at a different part, you might look at this line right here crossing with one of those. Those are actually crossing at a perfect right angle. If lines are perpendicular, they are also considered intersecting lines because perpendicular is just a special type of intersecting line. Let's look at this soccer field right here. So we're looking at these lines right here. Okay, this is crossing, you know, with the top and the bottom. Those are parallel. Those make those L shapes, okay? I mean, not parallel, I'm sorry, perpendicular, okay? Which is a special type of intersecting line. You might also look at a line here and a line segment here. These two line segments, these are the same distance apart going in the same direction. So those would be parallel lines. Let's look at some others. Look at this shape right here, this structure, this art, this modern art piece. This is a whole bunch of intersecting lines. Maybe if we saw it at a different angle, like this line looks like it might be intersect or perpendicular to this line, I'm not sure. And maybe these two, we don't have the best view on it, or this top one might be parallel to this one. But a lot of what we can tell is these are crossing at all different kinds of angles. So these are intersecting lines. So looking at this picture right here of this pavement, I see a lot of examples of perpendicular, okay? It's crossing at that perfect L shape, okay? But I also see examples of parallel lines, right? This one and this one, or even these two little line segments, okay? So we see a lot of different examples here. All right, these railroad tracks, it looks like we have some more parallel, but we definitely have some intersecting right here, okay? And we might even have, I can't tell what the angles of these. It's possible that these intersect at a perpendicular 90-degree right angle, but I can't tell for sure right here from my picture. Ooh, so these, it looks like I have parallel, you know, along each of these little slats right here, like where the blinds are on the closet door. Okay, but you also have some perpendicular where they cross, okay? So a few different things. If you count these shadow lines right here, you could almost technically say that these are intersecting with some of these other lines on your closet door. So it's interesting to see how they all kind of go together. All right, right here, it looks like this is a structure, and in the back of the picture, you can kind of tell where they're crossing and intersecting, okay? But these large beams at the top are kind of coming to a point at the top, so they're intersecting right there. Okay, this is a very, this is a common example of parallel lines, are these yellow lines in the middle of the road, okay, where they never ever cross, okay? This road, you know, you've got some parallel, and now from the perspective on this picture, this gets into art a little bit because of the angle of this picture. These do look like they would eventually intersect, but if you're driving on the road, they actually are an even amount apart, so they would be parallel. But these little yellow lines in the middle, they're going at different angles, and these would be intersecting lines, okay? All right, guys, that is all for today on parallel, perpendicular, intersecting, points, lines, line segments, rays, angles, all of that. It is so important to know these things because these help us understand more complex shapes and patterns and why things occur. So thank you so much for listening and happy practicing.